Hey there, focus learners. Welcome to another explainer. Today, we're taking a metaphorical road trip right into the beating heart of modern infrastructure, the Linux file system. If you're just stepping into the wild world of DevOps, understanding exactly where things live on a server isn't just a helpful tip, it is literally your fundamental map to survival. So, let's get started.
Okay, let's dive right into this with a question that represents an absolute, downright worst-case scenario for system administrators. What actually happens when you have 100 developers working on an application and they are all sharing one single root password on a production server?
Well, it's the ultimate nightmare scenario, right? Imagine one of those developers accidentally, or honestly, maybe intentionally, deletes a folder called sbin. Now, this holds all your core system binaries. The server just instantly dies. Poof. Core commands vanish into thin air, and because everyone logged in using that one shared root user, there is absolutely zero accountability. You have no idea who actually executed the fatal command. This proves exactly why proper file structures and strict isolated user management are absolutely vital to keeping any server environment alive. So to prevent that nightmare, here is our map of the server for today's explainer. First, we'll look at the shared server chaos. Then, root, the Google Drive. Third, settings and system binaries. Fourth, user homes and temp zones. And finally, number 5, the DevOps log lifeline.
All right, let's kick things off with part 1, the shared server chaos.
Listen to this staggeringly huge stat from our sources. 90% of production workloads run on a Linux server. 90%. So whether you are a developer, a quality engineering professional, or an aspiring DevOps engineer, mastering this file system is completely non-negotiable. I mean, it is the absolute foundation of almost everything running in the cloud today. To really illustrate the stakes here, let's introduce a theoretical DevOps engineer. We'll call him John. So John works at a major tech company, maybe Amazon, and he doesn't just manage one server. Oh no, he manages 10,000 Linux virtual machines. If he doesn't intimately understand the strict organization of the server, like exactly where configurations live, where logs are written, where binaries execute, managing those 10,000 machines very quickly becomes an impossible, incredibly chaotic mess. Which brings us to part 2, root. Basically, your server's Google Drive. We have to start at the root directory, which is represented by nothing more than a simple /. This is the parent location of the entire file system. It's where all files and folders are created by default. Think of it exactly like the parent folder when you open up a brand new Google Drive account. Everything, absolutely everything on the server branches out right from here. And this brilliantly illustrates how we can ground these kind of abstract, techie concepts into everyday things. The root /, that's your Google Drive parent folder. The etc. directory, that functions just like your smartphone's settings app. And the TMP directory, that acts exactly like the recently deleted photos folder on your phone. Connecting these dots makes navigating a scary Linux server feel so much more intuitive. Now, let's look at how this actually plays out in real-world cloud environments. On one hand, you have a Docker environment, which by default drops you straight into the root path. Boom, that gives you full administrative access immediately. But on the other hand, look at an AWS EC2 instance. Notice that it defaults to a path like home/Ubuntu. Cloud providers intentionally restrict your initial default path to a non-root user. Why? Basically to prevent you from accidentally corrupting the whole system right out of the gate. Moving right along to part 3, settings and system binaries. So, a absolutely crucial point on our tour is understanding the etc. folder. This is the true configuration hub of your Linux machine. It contains vital system files like the password file for user management, hosts for local DNS routing, and OS release, which tells you exactly what version of Linux you're running. Just like your smartphone's settings app or a Windows C drive, this is the master control room where the core system rules are defined. Now, what's really fascinating here is the separation of powers. Inside the user directory, we have user/sbin, which holds system binaries strictly for admins, things like the user add command. But then we also have user/bin, which holds regular binaries for everyone, like ls to list files or mkir to make folders. By physically separating administrative commands from regular commands, Linux administrators can safely restrict access. It's a built-in safety net, preventing non-admins from accidentally nuking the server. All right, let's shift over to part 4, user homes and temp zones. The home directory is basically the private workspace generated for individual non-root users. When an administrator creates users, they get very specific paths right here, like home/Ubuntu or home/Abi. This is where users store their private scripts, their code, and their files. Keeping things stashed here keeps them securely isolated from the rest of the public server and from other colleagues poking around.
Then we've got the temp directory. This is essentially a volatile storage zone for temporary files that just get automatically deleted over a certain time frame. Remember our recently deleted photos analogy? DevOps engineers frequently write automation scripts that drop transient logs or intermediate files right here in temp. That way, the script runs, it does its job, and the temporary data doesn't clog up your permanent system storage forever. It cleans up after itself.
And that brings us to our final stop, Part 5, the DevOps log lifeline.
The var directory stands for variable data, and honestly, most importantly for our tour today, it serves as the ultimate storage destination for application log files, which are specifically housed within var/log. When a web server crashes, throwing a nasty 502 bad gateway, or an application starts rapidly leaking memory, the var directory is the absolute first place an engineer looks to figure out what on earth went wrong. Let's actually walk through what that looks like in a real-life reactive troubleshooting scenario. Step 1, the application crashes. Panic ensues. Step 2, the engineer immediately navigates straight into var/log. Step 3, because those log files are usually massively huge, they use the grep command to search specifically for the word error to isolate the issue. This exact sequence right here, this is how DevOps engineers survive sudden system outages and restore functionality. It's their lifeline. But all of this actually brings up a really crucial final thought. Your logs are safely writing in var, and your system settings are neatly defined over in etc. But we are officially entering the era of AI ops. If an AI agent can read those logs, search for errors, and predict a memory leak way faster than a human ever could, what exactly is the future of the DevOps engineer? As tools evolve to automate this reactive troubleshooting, your role is going to shift from just reading the files to orchestrating the